Hello everyone, this is Mrs. Padmashri from SNS College of Engineering, Coimbatore. And today I'm going to discuss about VC dimension in machine learning. This was the continuation of my previous lecture, VC dimension. So these all definitions we have already studied. What is VC dimension? It's mainly used to measure the complexity of data in machine learning. And the formal definition also I had already explained in my previous video. Now, I'm going to explain the boundaries of VC dimension, bounds of VC dimension. What it is? It is help in estimating two important aspects of machine learning. One is the generalization error and other is the sample complexity. Okay, so the VC dimension, when we measure, it has both upper and lower bounds on the number of training example. It's mainly used to measure the accuracy level in the machine learning. Okay, so the upper bound of the training example is logarithmic in VC dimension, which we know we had already studied in the mathematics concept. What is a logarithmic operation? It is an inverse operation of exponentiation. Exponentiation. So it defined as the power to which the base number must be raised to get the given number. So the logarithm serves as mathematical tool that helps simplify the complex calculation involving in exponential relationship. So, in order to calculate the boundaries, upper boundaries and lower boundary levels of VC dimension, we use this mathematical logarithm and concept. So, example, suppose if I have the number 2 raised to the power 3 equal to 8, then we can write this particular number in the logarithm as 2 log base to 8, which is equal to 3. What is this generalization error? There are two concepts I said. One is a generalization error. Generalization error, which measures how well a model performs on unseen data. The VC dimension helps to bound this error using the following principles. Okay, it indicates a simpler model, reducing the risk of overfitting. What is the overfitting? So this we have discussed a lot about overfitting in machine learning. When a machine learns too much of information about the data set, then it is said to be overfitting. So while using this machine VC dimension concept, which is measuring the complexity of a machine learning. Suppose when we give the data set and the machine learns too much about the data set, which means what is the meaning of learning too much about the data set is instead of learning the what are the necessary features, the machine will try to learn all like errors, noise, everything from the data set. So it causes complexity in the data set, and also it reduces the performance of machine learning algorithm. So we need to generalize the error. It is reducing the risk of overfitting. So higher VC dimension allow the model to fit complex data patterns. So and it may leads to overfitting. This is a generalization error. And VC dimension and error bound formula. We have a hypothesis class $H dollar, which is said to be hypothesis class H and VC dimension D and a data set capital N. So the generalization error can be defined as error is directly proportional to capital N by D. So N represents the data set size. D is VC dimension. Okay. So largest data set, then the smaller will be the error. So even for model with higher VC dimension. What is the sample complexity? Sample complexity refers to minimum amount of data which is required for a model to learn effectively. It refers only the minimum amount of data. It provides insights to this requirements, and a hypothesis class with higher VC dimension requires more data in the data set to avoid overfitting. A model with lower VC dimension can generalize well with the with smaller data set. This is called sample complexity. And the key insight is in order to have a very good performance of machine learning algorithm, we need to ensure that the training sample should always be greater than or equal to D is a dimension, VC dimension values. And the step-by-step method to calculate VC dimension, identify the hypothesis class, first point. It is used to define the set of functions such as line, circles, or decision tree. Test for shattering. It determine maximum number of points classified on the every possible hypothesis class, and formal verification refers to a class that satisfies the condition of shattering n using the mathematical. What are the applications of VC dimension? Mainly used in machine learning and statistics, widely used in these two areas for analyzing the complexity of neural networks, and also used to design a new learning algorithm which are robust to noise and can generalize well, work well for the unseen data. Thank you.